Hey, what are you doing in there? Well, I guess since you're already in my kitchen, why don't I show you the basics of orthographic projection.
Architecture. Architecture.
Orthographic projection is commonly used in architectural design to eliminate perspective and create measured drawings referred to as plans, sections, and elevations. Today, I will be explaining each one of these types of representation and how to create them. Now, you may be wondering why we are in my kitchen. Well, thanks for asking. Today, I will be using fruit, an apple specifically, to represent a building, details, and merits of each of these drawing types. Let's start with maybe the simplest one, the elevation. An elevation simply represents a face of a building or space straight on, devoid of perspective. It is commonly used to represent the exterior facades of buildings or interior walls. As luck would have it, I'm baking one up in the oven right now. Oh, there's the oven. Let me see if it's ready. Now let's talk about a plan. I have a feeling you know the basics of a plan. It is a top-down view that cuts through the space horizontally. Typically, this slice is made at an opportune height so that it cuts through openings like doors and windows, thus creating respective openings on the drawing. So as you can see, that horizontal slice creates a view of the inside of the apple. Oh, there's my plan now. It's all finished cooking. As you can see, this drawing type is great for getting an organizational sense of the space, how wide and deep the spaces are, the proximity of rooms to each other, and how the circulation might work. It lends itself to a pragmatic analysis of space. Now let's consider the last drawing type, a section. Just as a plan cuts through the building on a horizontal plane, a section cuts at a vertical plane, slicing through foundations, floors, and roofs all at once. And if a plan is great for understanding the organization of a space, a section is great for understanding the experience of the space. With a section, you can see the relationship of eye lines, ceiling heights, stairs, sun angles, and more. Oh, I think my section is all finished cooking. So to review, we have an elevation, which is the side of the building. We have a plan, which takes a horizontal cut through the building. And we have a section, which takes a vertical cut through the building. And you can see I've used different line weights to denote different parts of the apple. A thicker line weight I've used where I've actually cut through the apple, so that's my cut line, and then I've used thinner lines to denote small details like seeds, stems, things like that. And you can see I've labeled each of these with a scale because technically these are 1:1 or actual size. Delicious. So now I'm going to use the model that I made for my modeling tutorial to create some more architectural drawings. So it's the next day. We had our fun with our apples. Now we're going to get more serious, and I'm going to use the model I constructed for our 3D modeling tutorial to talk about these same drawings. And we're going to get a little more serious, and I'll follow the same order: elevation, plan, section. And you can see I've just given myself some doors and windows, just enough information to kind of invent some drawings here. And if you're wondering, this is just chipboard, and I used some colored pencils to kind of like add shadow and color to some of the windows and doors and the facade as well. didn't do any on the sides because I thought this was enough to get me started, but most likely you will be working with a full building, so you'll have more information than I do. So let's go ahead and get started. I'll start again with the elevation, which should be pretty easy, I think. So essentially I'm just going to copy what I've drawn onto the model. I don't think I need to explain much there, so I'll just kind of speed through it. And I'm using some gridded paper, but you can totally do all this work in AutoCAD or Revit or whatever you are most comfortable with or interested in learning. And this portion is also easier for me because I have a real-life model to work with. So it's easy for me to take measurements, but again, eyeballing is fine, or estimating, however you can make this happen. Okay, so I finished my underneath sketch, so now what I'm going to do is just use some varying line weights to kind of establish some hierarchy in this drawing. And you can see I have a couple different, or I have kind of more details, some like mullions, some structural elements, and I'm going to choose to remove some of that just to make this drawing more simple. And again, that's something that you can totally control when we talk about how much information that you're providing with your imagery. You can totally embellish or simplify as you see fit to kind of increase the readability of the drawing. So I'll show you what I mean. I'll start with the thinner line weight and then I'll go thicker from there. With line weights, what you're doing is using different thicknesses of lines to denote different information or kind of establish a hierarchy of information. So typically a thinner line weight represents a smaller detail, like facade patterning, like a brick pattern, for example. And then in this example, I'm using a thicker line weight to establish where the window meets the window frame, where the doors are splitting so that they can open. And then I'm using my thickest line weight to denote where the building actually finishes, like the silhouette of the building. And if I were to do a side-by-side comparison, a drawing with line weights is usually going to read easier, convey more information than a drawing without line weights. Like I said, I removed some of the detail, like some of the door frames and some of the window details to enhance the readability of this sketch because I knew it would be kind of hand-drawn and loose. So I could, at this point, add like color and more details and shade and shadow, but I'm just going to move on to the plan. I'm just going to jump into that. And let's see, let's implement a scale. So typically doors are about 3 feet or just under a meter. So I have a double door here. So I would say that's about 6 feet. And that for me is about 1/2 an inch. So 1/2 an inch equals 6 feet. That would mean that, let me do some quick math here. So I'll put the math on the screen here, but if 1/2 an inch equals 6 feet, usually you want either the inch or the foot to be 1, so it's like a nice even number. So what I could do is multiply the inches, so I could say if 1/2 inch equals 6 feet, that means 1 inch is equal to 12 feet, so that would work. Or you could go the other way, and you could say, instead of 1/2 an inch is 6 feet, you could say 1 foot is equal to 1/12 of an inch, because that's 1/2 divided by 6. So with some pretty simple math and fractions, you can arrive at a manageable scale. So scale is, I'll do 1 inch is equal to 12 feet. And again, I arrived at that number by scaling off of my door. I know that typically doors are 3 feet wide, and I have a double door, which would be 6 feet wide, and then I just measured that length in my model, which is 1/2 inch. So I know that 1/2 inch is equal to 6 feet. Okay, so that was the elevation. Pretty easy, not too crazy since I already had most of the information. So now we're going to move on to the fun stuff. So let's start with a plan. And if you remember, I'll get my little apple here. A plan, oops. A plan is when you cut the building or object horizontally so that you're getting kind of a top-down planar view. So like I mentioned earlier, it's really important where you take this cut because, for example, if I were to take the section cut like here, right at the top of my paper, you would be missing all the information of the windows and doors of the first and second story, so that wouldn't really give us much of a plan. So what I'm going to do is cut right through the middle of my doors and windows on the first floor, so that way we'll see all those openings, and I'll kind of invent some other information on the inside. Again, you guys will have most likely a pre-existing building to work with and some drawings, so you'll have a better idea of what's going on inside. I'm just going to kind of make it up as I go, invent some staircases and things like that to give you examples of how you would draw those things. So I'm going to remain at my 1/2 inch equals 6 feet scale, or 1 inch equals 12 feet. And I'm just going to go ahead and get started here. So again, cutting right through here. Okay, there's the basic footprint of my building. You can see. Dun, dun, dun. So now what I'm going to start doing is translating information from my elevation onto my plan. So this is a good way to start and double check all your drawings. If you do your drawings and your orthographic projection correctly, all of your drawings should line up.
Hello. Unfortunately, at this point, my footage cut out, but I found this diagram on Google that I think explains this concept really well. So you can see on the bottom left-hand corner is an axonometric drawing representing the 3D form. It's this L shape extruded, and what I'm trying to explain is that all of these drawings, plan sections, and elevations are all drawing the same thing just from different angles, so they should in reality all meet up, which is what you see on the right-hand side. The front view lines up with the side view, lines up with the top view, and you can see they're in faint blue lines, they're all connected. So that's how you can kind of double check your drawings, make sure they're all coordinating with each other. Obviously, this is easier to do with orthographic shapes like this. Something more curvilinear with more detail and dimension will be harder to do, but this is the basic concept.
In plan, there wouldn't just be openings here, we have to actually draw the doors and the windows, and we talked about this a little bit earlier. So I'm going to use a thinner line weight, and you have to think, if you're cutting right through this building and looking straight down, this wall isn't just going to stop, it's going to continue, but we're not cutting through the wall where there's a window, so I'm just going to draw the wall kind of like the outline or the boundaries of the wall below it, because we still would see the extent of this wall. The door would not have a wall because it's a door, but for the windows there's this sliver of facade or wall beneath it, and that's the part that I'm drawing right now. Okay, and then for the windows themselves, it's a much thinner band of glass or glazing. So I would do a double line like that. I wouldn't fill it in with black just because it's a transparent material. So again, line weight is important because you can, line weight and poche is important because you can use it to represent different materials, like openings and things like that. There's a whole bevy of conditions that you can represent just by how you draw something. And then with the doors, typically those are represented shown open with an arc, or it's called a door swing. So that way you can kind of understand how the building is operating. These are exterior doors, and almost always, universally by International Building Code, those have to swing outwards in the event of a fire or internal disaster. people moving from the inside of the building outside don't have to open the doors inwards, because that could kind of cause circulation issues and trap people, so they always open outwards. So I'm going to draw those opening outwards.
I've also added some stairs, and there's lots of different conventions on how to draw stairs. This is one of them, where you draw the individual stairs as lines, and then obviously the stairs will most likely cut off above your plane that you've cut for the plan. So where that happens, you draw this little triangle-y pointed shape, and that indicates that there's a continuation of the stairs, but it's cut because of the plane. And then you can just indicate where the stair, if it's going up or down on the plan too, is important.
Okay, so now we have an elevation, a plan, and we're going to go to the last one, which is a section. So if you remember from our apple, section is when you cut vertically, and then you get a nice slice through the floor, the floors, the ground, the ceiling, any vertical elements like windows and stairs, all at the same time, depending on where you cut. Sorry, I got a little hungry there. So, you can see in my plan here, I've just added some stairs down the middle just to show us how that condition will operate. And so what I'm going to do is just cut right down the center of this building, and then I'm going to look this way. For this section, the orientation of the section doesn't really matter, because this building is symmetrical, whether you're looking to the left or to the right or to the left. But in your building, I would consider kind of different views. Typically, the conditions won't be so perfect, and you'll have more context to determine which direction the section is facing shows more information. Typically, that's the way you want to go. For this one, we're kind of devoid of context, and we have a symmetric building, so it doesn't really matter. So I'm going to start off the same way by creating the outer measurements of this building, and then we'll go from there. Okay, so there's a basic outer silhouette of my building. Hopefully you can see this. So I'm going to do a section cut right down the middle, and I'm going to look to the left. So we're going to see my stairs, some floors, and then a roof that I'm going to implement here. So I'm going to start with the information that I already know on the exterior facade, and then I'll work inwards. So just the same as the plan, we can kind of use our elevations to cross-reference these dimensions. So I should be able to line up my ground lines here. Hopefully this works better than it did in plan. Line that up. And then I'll just make some lines going across. So for example, the top of my door, I'll take a line right there. I'm going to draw a yellow line. It's usually helpful to draw this both on your plan and your elevation. Just going to draw a line right down the middle where I'm cutting my section through, and then I'm just going to do a little arrow at the top to indicate which direction this section is facing. So there, quite easily, you've represented, okay, here's my elevation, here's where I'm taking the section cut, and I'm looking that way. I'm going to do the same thing on plan. Take a line right down the middle, and do a little triangle facing that way. You can also label this like A, or whatever naming convention you want to use. And then this section could be labeled section A. So that's a nice way to keep all of your kind of drawings cross-referenced with each other and organized. Okay, so I have my door height. Let's go back. Oops. And I'm going to also do the height of these windows, and then I'll go from there. You can also do this obviously by just measuring instead of cross-referencing your drawings, but I want to show you guys how this is done. Bottom of that is there, and the top of this is right here. Okay, so now we have the section for my door. Oops. My door, this, middle windows and then this upper bay of this central window right here. So just like the plan, what I'm going to do now is draw in the wall thickness. I'm also going to pretend or invent a floor right around where my pencil is. So I'm going to go ahead and draw that in. So like I said, I'm going to go ahead and implement a floor in between my first and second set of windows there. But if you remember from my plan, I also have this set of stairs right here. So I'm going to also cross-reference this here. I'm just going to fold this to make this a little easier for us to see. So you can see my buildings now, or my drawings rather, are lining up, so I can just easily take this down. So that's where my stairs start. And then remember, these cut off right where they went through the plane of my plan, which was somewhere around here. So we don't really need to reference that line, but the stairs are going to go from here. Probably, I'll just, again, invent this. These stairs will not be super accurate slope-wise. See, they look very steep, but they'll work for this. And then I'll just add some risers here. And then there would be an opening in the floor so that people can get through. Okay, so now we have all of our major elements. Door, 2 sets of windows, stairs, and a floor. So now I'm going to take a nice dark marker and fill all that in to make this nice and readable. And remember, I'm going to poche everything that we've cut through, so that includes the stairs, so those get darkened as well. And then for sections, it's important to remember that buildings are attached, they're affixed to the ground. So when you're cutting a section, you're technically cutting into that ground plane too. So traditionally, that's the thickest line of a section drawing. It's this ground line. So I'm just going to do a double wide. So I'm going to do a double wide line that represents the ground that we're cutting through, that this building is sitting on top of. So now I'll go in with a much thinner line weight and do some of the details that we need. Remember, just like the plan, where there's a window, you still have a wall on either side and under it, so you'll still have a double line for that wall, as well as the store. And remember, last step, or doesn't necessarily have to be the last step, but I always am a big proponent of scale figures. I think they add a really nice touch of relatability and add a sense of scale. So remember, our scale is 1/2 inch equals 6 feet, which is about the height of an average person, maybe a little taller. So I'm just going to make a little pencil mark here at 1/2 inch in a couple places. Maybe one on the stairs too, climbing. But you can see now how much of an experiential diagram this is. Like, now all of a sudden we have these super steep stairs that open to this giant, like, triple heighted space. There's these gorgeous windows that you can imagine, these like huge beams of light coming through right here. So it really becomes a very evocative drawing style, whereas in kind of comparison to the plan, which is very organizational, very kind of pragmatic way to look at the space. And there we have it. So now with these 3 drawings, you pretty quickly get a good sense of what's going on the outside of the building and on the inside, both in plan and section. So I hope this helps in your crafting of your own drawings for precedent published, and thanks for watching.
Architecture. Architecture.
Why don't I show you the basis of, or for the